The most varied media are filled into and drained via pipes from tanks every day. Examples are potable water, fruit juices, oils and fuels, acids or brines. Since these media can have completely different properties, there are different measuring principles to detect them. For example, radiometric level measurement by gamma radiation. As early as 1896, Henri Becquerel experimented with uranium salts and found that these blackened a photographic plate, which indicated emitted radiation. He is considered to be the discoverer of radioactivity, and to honor him, the SI unit is called becquerel. 1 becquerel corresponds to 1 radioactive decay per second. In 1897, Marie Curie did further research on the radiation of uranium compounds and coined the word radioactive. To honor her, the activity measurement unit was called Curie. Radiometric instrumentation can be used to detect continuous level, point level, or density in tanks or pipes. This is usually done by gamma radiation. Let's have a closer look how this measurement method works. As a radioactive isotope decays, radiation is emitted in form of particles or electromagnetic waves. Alpha and beta radiation are particle radiations. Gamma radiation is an electromagnetic wave. In industrial instrumentation, cesium-137 or cobalt-60, which only emit beta and gamma radiation, are mostly used as radioactive isotopes. The isotope is installed in a double-walled stainless steel capsule, which shields the beta radiation completely. In industrial instrumentation, thus only gamma radiation is used. The radioactive radiation source is shielded by the source container in such a way that the gamma radiation can only be emitted in a certain direction. The source container is arranged on one side of the tank. On the opposite side, the compact transmitter is located to detect the radiation. This gamma radiation is used to radiate through tanks and pipelines from outside. As materials are penetrated, the radiation is attenuated by the density of the medium and the material thickness. The emitted gamma radiation is detected by the compound transmitter. As this occurs, a gamma photon of the scintillator is converted into a flash. This flash is transmitted to the photomultiplier in the scintillator, as is the case in a glass fiber line. In the photocathode, the flash is converted into a very low charge, which is then amplified to an evaluable current pulse in the photomultiplier. The same is then processed to become a measuring signal. The higher the level, or the higher the density, the more radiation is absorbed by the medium, whereby the radiation is reduced at the detector and converted into a corresponding measured value. Instruments according to the radiometric measuring principle of Endresen-Hauser facilitate the measurement of continuous levels, point levels, and densities, also in the most adverse process conditions, like high pressures or high temperatures, as well as in corrosive and abrasive media. We have the appropriate solution for any application. Endresen-Hauser.